Now, we need to find the area of each sector. Okay, so this is going to involve a new formula. Alright, so let me clear out my black screen here. So here's the formula for area. The area is going to be 1/2 r squared theta. Okay, whereas remember the arc length was simply r theta. The area of the sector is 1/2 r squared theta. So memorize that. Okay, so that's what we're going to be using here. They gave us degrees here. That's no good. We need to go ahead and convert that to radians. But you know what? I started to say, I thought maybe we had done 102 degrees before, but we haven't. So let's convert 102 degrees over into radians. So we can convert degrees to radians by multiplying by pi over 180. So basically that gives us 102 pi over 180, and then it's a matter of reducing this down. So I know that both of these are divisible by 3. Alright, if you add up the digits, 1 plus 2 is 3. So that's how I know this is divisible by 3, by the way. So if I do that, I'm going to get 34 pi over 60. Alright. Both of these are divisible by 2. So I'm going to do that now. Just cut them in half. Okay, so 34 divided by 2, that's 17 pi over 30. 17 is a prime number, so I know that's the end of the road for this. Okay, so 102 degrees is 17 pi over 30 in radians. Please make a note of it. So 17 pi over 30. Alright, now we can do the problem. Alright, using these radians. So I told you that, let's see, where shall I'll use this space right here. The area is going to equal 1/2 r squared theta. So let's see, so this is going to be 1/2 1.5 squared times 17 pi over 30. Just trying to squeeze it in here. Yeah, so might as well just, we're going to wind up using our calculator anyway, so might as well go all the way and just use our calculator for this whole thing. Okay, can I squeeze it? Okay, I'll just use this little screen right here to see what I'm doing. So I've got 1/2, and then I've got 1.5 squared and then I've got 17 pi over 30. Alright, it's got the whole deal. Boom. Alright, so that is 2.0. Cool. Alright, so to the nearest tenth, that is 2.0, and this would be inches squared, because we're talking about area, so the units will all be squared. So that would be the answer, number 43. Now, number 44 is already given to us in radians, so that makes life a little bit easier. So again, using our little formula of going 1/2 r squared theta, so this is going to be 1/2 3.4 squared times 4 pi over 3. And again, I'm just going to use my calculator because why not? Alright, sometimes they don't let us use a calculator, but if they're asking us for the nearest tenth, then, you know, they're giving us permission to use a calculator. So 1/2. Yeah, if we were supposed to find an exact answer, they probably wouldn't be giving us decimals for the radius. If it weren't for that, if this were just a 3, then we can square it and get 9, and we could do all this without a calculator. Okay, so just be emotionally prepared to be doing these problems without a calculator, because, you know, teachers are mean. Okay, so we have 1/2, 3.4 squared, 4 pi over 3. Ah, man, you guys, I'm not feeling great today because ice cream was on sale at Kroger. Got that Breyers vanilla. And I just ate too much. It was delicious, but I overdid it. Okay, so that's going to be 24.2. So there you go, 24.2 meters squared. All right, awesome. All right, on number 45, again, we will be using the formula area is equal to 1/2 r squared theta. This time they gave us radians for the angle, so we can just jump right in. So this is going to be 1/2 12 squared times 2 pi over 5. Alright, so this is 1/2. Now 12 squared is 144. And that's 2 pi over 5. So if they had asked us to find an exact answer, we really could this time. So let's see, half of 144 is 72. Well, this is silly because the I see the half and I see the 2, so it's basically like the 2 and the half are going to cancel each other out. So if I think of it that way, all right, if the 2 and this 2 cancel each other out, then I'm just going to be left with 144 pi over 5. I'm just showing you what you would have to do if they had asked you to find this exact. Alright, this would be an exact answer. Alright, yards squared. But we're doing this nearest tenth thing, so let's keep going. Whoa, it's bigger than I thought. So what did we have? 144, whoops, 144 pi over something 5. Okay, so that's going to be 90.5. Square yards. All right, so that's what it is to the nearest tenth. Okay, for number 46 they gave us degrees again, so 146, let's jump over here and convert that to radians. All right, and of course we can do that by multiplying by pi over 180 degrees. So this is basically 146 pi, I'm going to stop writing the degrees now, 146 pi over 180. Let's see, these are both definitely divisible by 2. So I know that's small potatoes, but that's what's jumping out at me right now, so I'm going to go ahead and do that. So this would be what, 73 pi over 90. I suspect that 73 is a prime number. So I think this is as far as we can go in terms of converting 146 degrees into radians, 73 pi over 90. So we're just going to have to do our best. Okay, so one more thing as far as the radius goes. Here they're showing the diameter. So we need to take half of this. Alright, so that's 10.7 is the radius. So watch out for that the radius is 10.7. So with all that in mind, we are now just using the formula. Whoops, I almost wrote S, but we're not doing arc length right now. We're doing the area, which is 1/2 r squared theta. Okay, so that's 1/2, and we'll have to do 10.7 squared. And we had to make sure that theta was in radians to be able to do this. Use this formula, which is very convenient. Alright, so we're obviously doing decimals, so I'm just going to put this entire thing in my calculator. Okay, my handy dandy TI-30XS multi-view. Boom. It's a lot of typing. So I am coming up with 145.9. Kilometers. Square kilometers, alright? Because we're talking about area here. So that would be the answer to number 46. Number 47, they gave us degrees again. So we need to convert 177 degrees into radians. 177 degrees. So we will convert by multiplying by pi over 180. So that's 177 pi over 180. I'm going to add up these digits. So that's 1415. 15 is divisible by 3. So that tells me that 177 is divisible by 3. Isn't that like magic? I love doing that. So let's do that. Okay, so that gives me 59 up there in the numerator. 59 pi over 60. Yeah. 59 is a prime number, so that's the end of the road for this. So 59 pi over 60 is the best we can do. Okay, and so now we will use our formula for the area of a sector, which is 1/2 r squared theta. So that's going to be 1/2 18 squared times 59 pi over 60. Now there are no decimals here, so if I wanted to, I could get an exact answer, but I'm not going to mess with that this time. Okay, so here we go. (18 squared) 59 pi over 60. Okay, that's the exact answer, by the way. Okay, so 500.5. Got to notice how you have to round that up because I've got a 5 over here. So 500.5 square feet. All right, that's answer number 47. All right, for this one, they gave us the angle in radians, so we can just go straight to the formula. 1/2 r squared theta is the formula for the area of a sector in radians. So the radius here is 43.5, and then the angle is pi over 12. Okay, I see the decimal here, so it would be really tough to come up with an exact answer without a calculator anyway. So let's just work the calculator. All right, 247.7. Got to round up. And the units are centimeters, so that means this will be centimeters squared. Square centimeters. And that's your answer number 48. The dartboard shown is divided into 20 equal sectors, as shown. If the diameter of the board is 18, which means the radius is 9, what area of the board does each sector cover? Well, the entire circle has an angle measure of 2 pi radians. So this is 2 pi radians, but it's been divided into 20 little slices. So if I want to find the angle measure of just one, I need to take the entire circle and divide by 20. So I'm just going to divide this by 20. This reduces down to pi over 10. So that is the angle measure. You know, that's our theta when we do the formula later. Okay, that is the measure of this angle in radians, pi over 10. Okay, yeah, you should know that 2 pi represents the entire circle. So anyway, now we can go ahead if we want to find the area of each sector. So the area of a sector when the angle is in radians is 1/2 r squared theta. So that's going to be 1/2. The radius is 9. So that's 9 squared times pi over 10. Okay, now one more time, if they did ask us for an exact answer, we could find it. Okay, 9 squared is 81. Okay, so this would be like 81 pi, 2 times 10 is 20. 81 pi over 20. So this would be an exact answer. Don't forget the units. Inches. Okay, but let's go ahead and do this to the nearest tenth. Alright, but if you didn't have a calculator, then this is what you would have to do, and we call that an exact answer. Alright, that is 12.7. Alright, so that's the answer to the nearest tenth. Okay, and the problems are changing now, so this is going to be a good place to stop this video. I will see you on the next video. I hope it was helpful.